Hello, we are Yıldız Rover team from Yıldız Technical University in Istanbul. We are an interdisciplinary robotics team established in 2018. We are proud to introduce to you our team and third generation rover Gökmen. Our team has been participating in URC, ARC, ERC and Technofest since 2022. Last year, we achieved 22nd place at URC and 2nd place at ARC.
Our team adopts a professional approach to task allocation and scheduling. We manage data transfer, meeting scheduling, task assignment, and the data archiving through the Notion database and Discord. We build our rover at our workshop located at Yıldız Technical University and conduct tests on the extensive grounds of Davutpaşa campus.
The rover chassis consists of T-slot aluminum profiles, ensuring lightness, durability, and easy modification. The rover is designed to be 37 kg, along with the mission-specific record installed system. This weight can reach up to 50 kg.
Positioned at the rear, the differential bar in the rocker suspension system is made of aluminum profiles to guarantee high bending stress and vehicle stability. This design choice contributes to a more balanced ride with reduced force exposure. The rover exhibits the capability to climb up 45 degrees slope with brushed DC motors, generating 20 Nm torque and airless T2 tires. The drive system enables the rover to traverse harsh conditions efficiently.
6 degrees of freedom robotic arm that utilizes the combination of brushed, brushless, and servo motors is composed of aluminum profiles, carbon fiber profiles, and PLA materials to reduce the rover's overall weight. The robotic arm measuring 1200 mm in size and 9.5 kg in weight has the capability to reach up to 1000 mm away and carry loads up to 5 kg. The robotic arm excels in providing high precision thanks to a cyclade, differential bevel gear, and belt pulley mechanism composed of cast polyamide, aluminum, and TPU. The two-fingered adaptive gripper is capable of providing full rotation. The gripper is designed with flexible TPU for ensuring both parallel and round grip along with wide grasping ability. The fingertips are sufficiently hardened with PLA to prevent slipping that may occur due to the slippery nature of TPU.
We choose 6 serial 13 parallel Li-ion battery pack to safely provide sufficient current and voltage to all electronic equipment in rover's electronics box. For safety, we used battery management system, which protects the battery from undesirable conditions. We designed custom-made PCBs such as power distribution, motor driver, robotic arm, switching and encoder with STM32 series microcontrollers on them. Our power distribution board has features such as reverse polarity protection, INA current sensor, and fuses at the outputs. These designs provide overall reliability, better control, and durability to the rover. Considering emergency scenarios, an easily accessible emergency stop button has been placed on the rover, which can unconditionally shut it down.
CAN bus and UART protocols were chosen for wired communications in the rover. 5.8 and 2.4 GHz omnidirectional antennas were used for the communications between rover and base station.
We improved our previous work based on deep reinforced learning-based autonomy with three-dimensional analysis support, so we can easily travel in rigid and sloped conditions. For the real-time location accuracy of our rover, a long short-term memory-based sensor fusion model that's combining the stereo camera, Biona 55 IMU, real encoders, and RTK GNSS was designed and trained in real-life conditions. Combined location and motion data are brought together in integrated Qt-based and a real map-supported mission planner. Planner can tolerate connection interruptions with the ability of to automatically switch connection frequencies.
Thanks to the image datasets we have created, we can recognize objects and oracle labels, instantly determine their location and relative angles and include them in autonomy. The ARM software combines the edge transformations and inverse kinematics calculations and tested and verified in the bullet physics environments with the PID algorithm on the Arduinos by communicating with ROS.
We conducted our studies towards the fields of exobiology and geology by examining the biochemical and microbial activity of the organisms. The science mechanism is equipped with analysis devices, biochemical tests, and several sensors in the purpose of performing experimental analysis. To comprehend an unknown environment, we use our gas sensors to observe the suitable life conditions by detecting vital atmospheric gases and air quality. The soil is collected by the gripper using scoop-shaped fingers, then distributed to containers in the rover. Our science mechanism also contains a revolver that has a filtration system to prevent the residues left and prepares the sample for specific measurements, such as NPK, pH, humidity, and temperature.
The collected samples are kept in a removable container isolated from the outer environment to apply tests in accordance with our scientific hypothesis and further observations. Also, near-infrared reflectance spectroscopy is specifically selected to measure the requirements of the solid matters, such as rocks, in higher nanometer ranges. To determine the structural composites of the samples, a digital microscope is used to facilitate analyzing the rock types using the interface that is designed by our team.